Alright, after 5 minutes break, let's come back. We start the section 5, sample space having equally likely outcomes. So that is like the basic assumption for the outcomes in the sample space. Then in this way, we can evaluate some probability of some special event we define. So let's check the formulas. So in many experiments, it is natural to assume that all the outcomes in the sample space are equally likely to occur, or usually we can say that each outcomes will have the same chance to occur, right? Now let's review the examples of flipping two coins, okay? Flipping two coins, and flipping two coins, sorry, let me go back. Let me change to pen. So flipping two coins, we will have the sample space. There are 4 different outcomes. You will get both head, tail, and tail head, and both tails, right? Both tails. So what does equally likely outcomes? Which means each outcomes in the sample space, they have the same chance, which means each one, the probability of each outcome occurs will be 1/4, right? Will be 1/4. So you get double head, the probability of this outcome will be 1/4. The probability you get head and tail, 1/4. The probability you get tail and head, 1/4. The probability of double head tails, you will get 1/4. That means the equally outcomes, right? So it's pretty easy, right? It's pretty easy. And let's work out one event. For example, we define the event, at least one head occurs. Okay, we define the event E in this way. At least one head. So we have seen the phrase at least a lot of times, right? At least one head occurs. So the event E will be the outcomes will be consist of the outcomes double head, HT, and TH, right? That means at least one head occurs. At least one head occurs, which means one head occurs, including those 2 outcomes, and both head occurs. So what is the probability of event E? Without any calculation, you understand that this is 3/4 because you have 3 outcomes in event E and over the total outcomes in the sample space, right? So how we understand the probability of this event is 3/4. Then let's check the formula here, okay? So from the axiom 3, for any event E, okay, for any event E, of course, E is a subset of the sample space. When we mention the event E, that is the subset of the sample space. So we define the probability of event E, that is the number of outcomes in event E over the number of outcomes in S. And usually we use the small letter m. We use n to denote the total number of possible outcomes in the sample space. So it will be the number of outcomes in E over m. So this is based on the assumption all the outcomes in the experiment are equally likely to occur. Okay, when we're talking about the probability, if you are going to use this one, and this is like very simple probability, okay, equally likely, and in future we are going to discuss the probability about more complicated scenario if they are unequally likely to occur. Okay, so the probability of any event E equals the proportion of the outcomes in the sample space that are contained in E. And especially from here you can also verify all those axioms. Okay, you can also verify all those axioms if we define the probability function in this way, it will still satisfy all those axioms. So basically we can check that axiom 1, okay, axiom 1. So if we define the probability of event E in this way, of course it will be between 0 and 1, right? It will be between 0 and 1. And if the probability of event E equal to 0, what is the name of this event? Null event, right? Which means there is no outcomes in the event E. So the numerator is 0. So it's 0 over m. And then axiom 2, sample space. What is the probability of the sample space? You can take the sample space as a special event. So the numerator becomes the number of outcomes in the sample space over the number of outcomes in the sample space. Of course, it's 1, right? And by the way, the number of the outcomes in the sample space is not 0, right? The sample space cannot be null event if you are talking about an experiment. If you are talking about an experiment, that should be outcomes occurs without uncertainty. So it should be some outcomes. So the number of outcomes in sample space can never be 0. And then we were not going to talk about axiom number 3. That will be more complicated case. But you can just simply check the proposition. The proposition 4.1, right? If we have two events like the probability of E's complement, that will be 1 minus the probability of E, right? Here the 1 minus, think about it, 1 minus the number of outcomes in E over the number of outcomes in S. That means the probability, the number of outcomes not in E, right? Not contained in E. What does not contained in E means? Means contained in E's complement, right? It's the same way. It's the same thing. So we define the probability of event in this way. That also satisfy the axioms. So this is the probability function. So it's pretty easy, okay? Pretty easy. But we are going to talk about several examples to with the equally likely outcomes in the sample space. So the first one, let's just review this experiment. Tossing 2 dice, right? Tossing 2 dice. So tossing 2 dice, each die we will have 6 different numbers. The second die we will also have 6 different numbers. So the combination will be 36 different combinations, right? Different combinations or different outcomes. And by the way, you get the number 1, 2, 2, 1. They are different, right? 1, 2 means the first die you get the number 1. Second die you get the number 2. 2, 1 is in another way. So if 2 dice are rolled, what is the probability that the sum of the upturned faces will equal to 7? Will equal to 7. So you can define this event. Okay, you can define this event. E means the sum of the 2 dice numbers equals 7. We are going to list all those outcomes. 2 dice numbers equals 7. Okay, equals 7. So we are going to list all the outcomes in event E equals 7. Be careful, here should be each outcome should be a parenthesis, right? So we are going to have 1, 6, right? 1, 6. I'm going to do the increasing order for the first number. 2, 5, 3, 4, 4, 3, 5, 2, 6, 1. Any others? We are not going to have 0, 7 or 7, 0, right? You are not going to see the number 0 is showing on the die. So how many outcomes in event E? 6, right? Probability of event E will be the outcomes in event E6. How many different outcomes in the sample space? 36. So it's 1/6, right? That is the probability of the event E. The sum of two dice numbers equals 7. And you can define several events to ask the probability. For example, I can define I can pop up several questions. I can pop up several questions. So question 1, I'm going to call the event A. Let me just pop up several questions and ask the students to answer it in a quick way. Just very simple, right? Apply the formula PE. So the first question, if I'm going to define the event A is the number on the two dice are the same. What is the probability of event A? That is the first question, PA. And then probability event B. The sum of the two dice numbers is less than 5, or the third question. There are several questions pop up to work out the probability. So event C, the sum is greater than 10, is greater or equal than, or greater than or equal to, is greater than or equal to 10. Now I'm going to ask 3 students to answer the probability of each one. Jasmine, are you available? I think Jasmine also take this course. Jasmine, what is probability of event A? Please answer in the WeChat group. So Jasmine's turn, and then I'm going to ask the second one. So Jasmine, you should answer the probability of event A. Then Tariq, probability of event B, PB, for the second question. And then red one, probability of event C, PC, answer the third question. So those 3 students are called to answer the probability of A, probability of B, probability of C for those 3 questions. Please write your answer in the group, then we can check a little quick. It's pretty easy for this example, right? Yeah, Tariq, answer second question. All right. So we will leave those 3 questions, We will leave those 3 questions. Now, let's continue more examples, Let's continue more examples. So the second type of, the first one is just the basic one. We review the experiment. Two 2 dice are tossing. Okay. Now we are going to talk about one typical type of the example, balls drawn. Okay, balls drawn. There are a lot of questions can pop up with this type of scenario. Some balls are drawn. So let's read it. If 3 balls are randomly drawn from a bowl containing 6 white and 5 black balls, what is the probability that one of the balls is white and the other 2 black? So let's try to understand. What is the event they ask. Okay, what is the event they ask? And we will compare with the combinations. Okay, combination we discussed in the first chapter. So here we have 6 white and 5 black balls. So totally we have 11 balls, right? 11 balls. So how many different combination here? Here the order does not matter. Make sense? We choose 3 balls randomly selected. If you choose, for example, if you choose white number 1, white number 2 plus the black first one, it doesn't matter. You choose the second white, first white, and then the first black. It doesn't matter about the order. You only have you put all those 3 balls together when you draw, right? It doesn't matter which one you choose first. So the order does not matter, which means we are going to do the combinations. So totally we have 11 balls. So will be 11 balls, choose 3, right? 11 balls, choose 3. So what is this event? This event E will be 1 is white. 1 is white and 2 are black, right? So how many different combinations for event E? How many combinations for event E? So for event E, the combination will be, you choose 1 from white. How many white totally we have? We have 6. You choose 1 from the white, right? So you choose 1 from 6. And then this is the steps, like, right? You are going to choose 3 balls. You are going to choose 3 balls. So step 1, you are going to choose the white, right? You are going to choose white, 1 white. And then your step 2, you are going to choose 2 black, right? 2 black. So that is 2 steps. Between the steps, you will do the multiplication. So we finish the first step, we choose 1 ball, and then we are going to choose 2 more from the black. So the total will be 5. Choose 2. Then you finish, you choose the 3 in this way. So that is event E. We can make sure we have 1 white and 2 black, right? 1 white and 2 black. And then what is the outcomes in the sample space? What is the outcomes in the sample space? In the sample space, that means 3 balls are selected, are drawn, right? 3 balls are drawn from how many in total? Are drawn from totally 11 balls. That is the sample space interpretation. 3 balls are drawn from 11 balls. So how many different combinations we have? 11 choose 3. So what is the probability of event E? That will be the different outcomes in event E. This is the different outcomes in event E over the different outcomes in sample space, right? In the sample space. And by the way, how can we work out these final answers? How can we work out the final answers? So let's simply do that. So here, 6 choose 1. 6 choose 1, which means we only have 6, right? We only have 6 actually. you can just do 6 factorial over 1 factorial, right? Over 1 factorial times 6 minus 1 5 factorial. 6, think about it. 6, you are going to choose 1. So of course you are going to have 1. You are going to have 6 different outcomes. So the 5 factorial will be 5 times 4 over, sorry, should it be 5 factorial? Let me just follow our combination formulas, okay? Combination formulas. So that will be 5 factorial over 2 factorial times 5 minus 2, 3 factorial, right? 3 factorial. And 11 choose 3, that will be 11 factorial over 3 factorial and 11 minus 3, 8 factorial. Okay, then finally you can calculate the answer. The answer finally should be 4 over 11. Okay, 4 over 11. So that is the first one. Okay, in the board we have 2 different colors for the board, and you are going to choose some from one. Choose different numbers with the colors. Okay, you are going to have some restriction for the boards from the colors. You have 1 white, you have the other 2 are black, and also I can change the question into what is the probability that so you can think about, let me write it here. You can think about the question by yourself, okay? Pop up some questions based on this one. So I can define my event A. What is the probability 3 balls are white? What is the probability when you draw the 3 balls are white, or when you draw the 3 balls are black? So which means when you draw the ball, what is the event when you draw the 3 balls are the same color, right? Either white or black. Or you can think about, like we have another event B, you draw 2 white plus 1 black. You can think about the probability. This one means black, okay? This B means black color. So you can think about the probability of those events. So that is the first one, okay? That is the first one. Second one, okay? Second one, it's still like it's the same like the board's drawn. A committee of 5 is to be selected from a group of 6 men and 9 women. So that means totally we have 15 persons, right? For 15 persons, and we are going to randomly choose 5, right? So the sample space will be 15 choose 5. If the selection is made randomly, what is the probability that the committee consists of 3 men and 2 women, right? This is similar like you have 2 colors of the balls. So here, let's solve it. So sample space means 5 persons randomly selected from 15, right? From 15 persons. So the possible outcomes in the sample space will be 15 choose 5. And what is the event E here? Or you can call event A. It doesn't matter. You use a different capital letter. So here means we choose 3 men and 2 women. So this is still like the choosing balls. You are going to finish. You are going to choose those 5 persons in 2 steps. So you are going to choose 3 men. How many in total? 6, right? We are going to choose the 3 men out of 6. That is the first step. You choose 3 persons, and then you are going to choose 2 women out of 9, right? Out of 9. So the probability of event A. So all those examples, we assume that each outcomes, which means each different outcomes, they will have the same probability to occur, okay? The same probability to occur. So to work out the probability of A, that will be the different possible outcomes in event A times the outcomes over the outcomes in the sample space. And again, you can follow the combination formulas. 6 factorial over 3 factorial times 3 factorial, and then times 9 factorial over 2 factorial times 7 factorial. And usually I would like to do in this way, okay? So 15 choose 5, that means I have 15, I have 5 numbers. 15, 14 times 13 times 12 times 11. And then actually that is the same. This denotes the 15 factorial over 10 factorial, this part, then over 5 factorial, okay? So I usually would like to write this way, so you don't need to write over 10 factorial. So finally we work out the probability, that is 240. Let me check the final answer. That is 240 over 1001, okay? And this ball drawn, this type of example, ball drawn, can be more complicated if you have 3 groups. Here we only have 2 groups, for the balls, the white color and the black color. And here we have the men and women, 2 groups. If you have 3 groups, that will be multiplication of 3, okay, of 3. So that is the example for the ball drawn, okay. Now next we are going to let's finish this one, okay. This one is a little more complicated. Then we will play with cards, okay. We're going to play with cards. So any questions so far to work out the probability? Any questions? Now let's read this example. An arm contains n balls, okay, n balls, one of which is special. So out of the n balls, only one is special. If k of these balls are withdrawn one at a time, with each selection being equally likely to be any of the balls that remain at the time, what is the probability that the special ball is chosen? Okay. So here, out of the n balls, we have the one is special, and need to take note. You need to take note for those examples. Or any questions? Any questions based on the previous 2 examples? So any questions about the first and second balls drawn? I think you take note of this part. That will be enough, okay, to work out how you work out the probability of this event. So if you can take the notes for this part, that will be enough. Then you can do the calculation by yourself after the class, okay, after the class. And those 2 are pretty easy. Now let's continue this one, okay. So the sample space, okay, the sample space will be this S, the second S means my sample space, okay. Sample space will be k balls are randomly selected one at a time, right? Drawn from n balls, right? How many different outcomes? How many different outcomes from n balls? So different outcomes will be n choose k. They are drawing one at a time. So here the order does not matter. The order does not matter. So what is the probability that the special ball is chosen? So we can name this event E. Special ball is chosen. Special ball is chosen, which means this ball is included in this K balls, right? Special ball is chosen. So you can divide the experiment for event E as 2 steps, okay? As 2 steps. step 1, you can choose the special ball. This one ball, okay, we just call special ball. We choose one, okay, we choose this one special ball. And then step 2, you are going to choose step 2, you are going to choose the other k-1 balls. Make sense? So because totally you are going to choose k balls, right? You are going to select it k balls. So the first step, you are going to choose one special ball out of n. So you only have one. You only have one outcomes. You fix this one, right? And then you are going to choose k-1 balls out of how many in total. So now, without this one special ball, the total we have n-1. And then we are going to choose k-1 out of the total. So that will be 1 times k n-1 k-1, right? So here the probability of event E will be the outcomes in event E to have the special ball is chosen. You can represent this one means you have one special ball, you choose one from it, right? You can divide the group of the sample space also as 2, okay? Balls in sample space. It's also like the color we did, okay? The balls in the sample space, two groups, special ball and the other. And especially how many balls for the special, the others, right? Two groups. You have two groups. Special ball total is 1. The others total we have n-1. So it's the same, right? It's 1 choose 1. You choose the special ball and then times the second step. You are going to choose a k-1 from the other group. The others are the same. That is the outcomes, the total number of possible outcomes in event E, then divided by the different outcomes in the sample space, of course, is n choose k, right? N choose k. Let's work out. So here, 1 choose 1 is 1, right? You only have one choice. Here, n-1 choose k-1, so you can do n-1 factorial over k-1 factorial. And then n-1 minus k plus 1, right? So that is like n minus k factorial for the top. And then n choose k is n factorial over k factorial, n minus k factorial here, right? So let's cancel some term. Sorry. Let's cancel some term. So here we have n minus k factorial cancelled. So n-1 factorial cancelled, so we leave the n, right? k-1 factorial cancelled, we leave the k. So it's n over k in the denominator. So you flip this k to the top. That is k over n. It's pretty easy to work out the final example, to work out the final, okay, the final answers. So I think it's pretty easy to talk about the balls are drawn. And we have more examples about the ball drawings in the textbook. You can read it. And there are some other ways to interpret this kind of event. So any questions so far? Have you finished the note? I'm going to start the card, okay, the card examples. All right. Let's move to the cards drawn, okay? Let's move to the cards drawn. So a poker hand, consists of 5 cards. Okay, 5 cards. If the cards have distinct, here totally we are talking about the 52 cards. Okay, 52 cards. 52 cards. We have 4 different shoots: the diamond, the heart, spade. What is the other one called? Cube. That one. So we have 4 different shoots, right? 4 different shoots. Each shoot we have 13 cards, right? 13 cards. We have S, 2 until the number 10, and Jack, Queen, King, like that. So 52 in total. If the cards have distinct consecutive values and are not all of the same shoot, we say that the hand is straight. For instance, a hand consisting of the 5 spades, 6, so it's 5.5, the 5 point in spades, 0.6 in spades, and 7 in spades, but 8 in spades, but the 9 is in heart. That is called a straight. What is the probability that one is dealt a straight? So one got a straight with a 5 card. So here we need to think about the case when we have 5 distinct values, but they might have the same shoot, right? They might have the same shoot. Now, let's illustrate the sample space, possible outcomes, and the outcomes in the event. Okay, in the event. So sample space, 5 cards, choosing from, because one person only get 5 cards out of the 52, right? 5 cards chosen from 52. Then the different possible outcomes will be 52 choose 5. That is the different outcomes in the sample space. Now I'm going to define the event E. Okay, this event E we need to spend some time to figure out. So let's think about the sequence, the consecutive values first. Okay, so you can do like the 5. Let's think about the value first. Okay, 5 consecutive values. So you can have, for example, you can have the 5 consecutive value. I'm not talking about the shoot first. Okay, I'm talking about the value first. Let's focus on the value first. Figure out one by one. So you can have S 2, 3, 4, 5. All right. So here they take the S just as 0.1. You can have this one, and then from here you can have 2, 3, 4, 5, 6, or 3, 4, 5, 6, 7, like that, right? You can have several ones. What is the final one you can have? So you can have the most one is 10. You starting from 10, Jack, Queen, King, and S. Okay, where did you find 52? Usually the cards they are talking about is the 52. Okay, is the 52. We don't have the 2 extra. Like I think I introduced this one before. We have 4 shoot. We have 4 shoot for the cards, and each shoot you have 13 cards. So that's why we have 52. And usually we have 2 more cards. The total number should be 54, and that 2 will be removed. That 2 extra will be removed because they didn't count. They didn't count anything. Okay, they didn't count anything. Usually in the probability we are talking about, but maybe really when you play the card, you need those 2 extra. Okay, those 2 extra. So here, let's talk about the 5 consecutive values here. So you can have the first one is S2345, 23456, or 34567 until the last sequence. This is the first sequence. And until I'm going to put the increasing order for the first card, then you are going to have the last one is the 10 Jack, Queen, King, S, right? So how many of those sequence you can have? How many? Let's call someone to answer. Rakib? Rakib? So how many different sequence we are going to have? If we put the first number in an increasing order, how many different consecutive sequence we can have, or how many straight? For example, you are one player, you are going to have those cards in your hand. How many different street you will have? You can have S2345, you can have 4, 5, 6, 7, 8, and finally you can have 10 Jack, Queen, King, S. So Rakib, how many different street we will have? Not available? So we are going to have, this is like 1, right? This S work as 1. So we will have 10 different street. And here, basically I'm only talking about the numbers, okay? Numbers. Not about the shoot. We will talk about the shoot later. 5 different street. Or we are not called the straight, okay? Straight means different shoot. Not the same shoot. So 5 different 5 different sequence, okay? 5 different sequence. 5 different sequence for the 5 card. So we are going to have 5 different sequences. So in this way, you might have all those like S2345. You might have all those in the same shoot. How many in the same shoot? Here, how many in the same shoot? We are going to have, for example, the first one. For example, the first one, you are going to have 4 different shoot, right? I mean, if they are the same shoot, because the street means they are not all the same shoot. So which means you can have at least 2 different shoot. So I'm talking about for each sequence, they are going to have 4 different same shoot. Make sense? So like this S2345, you can have the spade, you can have the heart, you can have the diamond, you can have the cube. Only 4, right? Only 4 with the same shoot. Then how many in the total? Each sequence you are going to have 4 in the same shoot, right? In the same shoot, which means you have 4 in the same shoot and until the last one. So totally we will have 10 times, because we have 10 this kind of sequence, and each one we will have the 4 shoot, which means they are not called straight. Those 5 cards are spade. All those 5 cards are spade. They are not called straight, right? Or if all those 5 cards are in the same shoot, they are not called the straight. So 40 different consecutive 5 cards, but in same shoot. But in same shoot. But in the same shoot. Right? This is the part. This is the part in the same shoot. Now let's consider. Okay. Let's consider all those. Okay. Let's consider all those. So here we are going to check. So I'm going to put the 5 sequence values. So for example, if it's starting from the S, let's continue the event E. Okay, let's continue the event E here. So I'm going to try for the first card. I'm going to choose those 5 cards as one hand. Okay, as one hand. So if I decided the first one is S, how many different shoot I can choose? I have 4, right? I have 4. And then the second one, the number is fixed. When you choose the S, the second one, the number is fixed, but how many different shoot you can choose? We don't need to consider if the shoot are the same. So still we have 4 shoot, right? Still we have the 4 shoot. And then for the third one, for the third place, the number is fixed, right? The number is fixed. So the number is fixed, and then different shoot we will have 4 also, right? We will have 4 also. And the fourth one, the number is fixed, 4 different shoot. So that will be 4 to 5, right? 4 to 5. But in this way, for example, if you choose spade, you might have the case you choose the others are all spade. But we already count for all those, okay? We already count for all those. They have the same shoot for 5 consecutive. For all those sequences, we will have 40, so will be minus 40. Okay, will be minus 40. And this works for all the sequence. When you decided the let me it's not right. Okay, it's not right. It's not equal minus 40 here. So here is when you decided the first number. When you decided the first number is the S, then you can have 4 times 5. When you decided the first number is 2, then you can also have 4 to 5 different combinations. 2, 3, 4, 5, 6. So how many different sequences we have? If you decided S, if you decided 2, if you decided 3, until you decided 10, right? You decided 10. So actually, totally, we will have. This is to consist your 5 card. When you decided the first number, you have 4 to 5 different combinations, including they are the same shoot situations. So we have 10 different sequences. That will be 10 different sequences. And then they might have the sequences with the same shoot, but we should remove this with the same shoot. With the same shoot, they are not called the straight. Okay, they are not called straight. Straight means they have the 5 consecutive value, but not all of them are shoot. So we should remove the case 40. That is all the possible outcomes in E. Okay, so that is different outcomes in E. Outcomes in event E. Then what is the probability? Okay, so the answer. Okay, the answer. What is the probability of event E? That will be the probability the probability, the outcomes in event E, which will be the 4 times 5, 4 to the 5, which means for each sequence you will have 4 to 5 different combinations, and this including the same chute, like you have all those five cards are in the same chute, in spade or in heart or in cube or in diamond. So we have 4 to 5, and then we have 10 different, totally we only have 10 different sequence, and we should subtract it with the total 40. They have the different consecutive 5 cards, but they are in the same chute. This is not called a straight, right? The event E is a straight. So divided by the total 52, choose 5. That is the probability of event E. And finally, you work out the answer that will approximately be 0.0039. You should keep more decimal numbers. You are not going to have 0. Okay, it can occur, right? We play the card. It can occur to get a straight, of course, with very small probability. Okay. So trying to understand this scenario. It's almost time today. We're going to stop here, and there are one more example. You can read this one by yourself. Okay, it's about the full house. Okay, the full house. A 5-card poker hand said to be a full house if it consists of 3 cards in the same denomination and 2 other cards in another denomination. Okay, they are not the same. So it's like you have 3 spades, 2 heart, like that, or you have 3 heart and 2 diamond, in that way. Okay, then a full house is 3 of a can plus a pair, right? That is what they call. So what is the probability one is dealt with a full house? You can think about this probability by yourself. So it's almost time. We will stop here today.